Hi everyone, this video is focused on the structure and maintainability of our project, TaskForge.net. I'll walk you through its structure and explain how we applied clean architecture, dependency injection, unit of work, generic repository, and more, all to make the application robust, scalable, and maintainable. Let's start with the big picture. We followed a clean architecture approach, which organizes the project into four main layers. Domain contains core business entities. Application contains service contracts and business logic. Infrastructure handles data access and external dependencies. WebUI, the presentation layer with controllers and views. This separation of concerns allows us to keep the codebase modular and easy to maintain. Now let's see the domain layer. This is where we keep our core entities like project, task item, and user profile. Each entity inherits from a common base entity class, which provides shared properties like ID, created date, modified date, and a isDeleted Boolean flag for soft delete. We also have enums here such as task priority, task workflow status, and project role, which help enforce consistency. This layer has no dependencies on other layers. That's one of the core principles of clean architecture. Dependencies point inward. Next, let's move to the application layer. This is the heart of the application logic. Here we define interfaces for services like iProject service, iTask service, iUser profile service, and repositories like iProject repository, iTask repository, iUser profile repository, DTOs for sending and receiving structured data, business rules such as validation and conditional logic. Services are written against abstractions, not implementations, which keeps this layer independent and easy to test. For instance, our project service depends on iProject repository, not the actual database. Now on to the infrastructure layer. This is where we connect to external systems, mainly the database. We use Entity Framework Core with SQL Server. Here we've implemented a generic repository pattern for shared CRUD operations, specific repositories like project repository or task repository for complex queries, a unit of work pattern, which ensures all DB operations within a transaction are committed or rolled back together in the save changes async method. Next, let's look at the WebUI layer. This is our presentation layer, and it's built with ASP.NET Core MVC with controllers and views to handle user interactions. We've organized controllers by feature. For example, project controller for project-related actions, task controller for task management, project invitation controller for inviting team members. These controllers are thin. They handle HTTP requests, validates user inputs, make view models, and send it to the view. All dependencies are injected using ASP.NET Core's built-in dependency injection system, which we configure in program.cs during startup. We've also added basic bootstrap styling to ensure the UI is clean and responsive. As I mentioned, dependency injection plays a huge role in our architecture. This ensures loose coupling, easier testing, and cleaner code. And also we use Serilog for logging. Now let's open our test project. We use xUnit for writing unit tests and mock for mocking dependencies. This approach ensures we don't need a real database for testing, and we can verify the business logic independently. We've focused mainly on testing the application layer, especially services. We have done for others also and got an 80% plus code coverage. Let's quickly summarize how our structure ensures maintainability, separation of concerns via clean architecture, loose coupling using dependency injection, reusability through generic repository, consistency with centralized DTOs and services, testability through xUnit and mock, scalability due to modular folder design, observability with integrated logging using Serilog. All of this ensures that we can easily add features, fix bugs, or onboard new developers without slowing down. That's the structural overview of TaskForge.net. This architecture has allowed our team to collaborate effectively, make clean commits, and write maintainable, testable code throughout Learnathon 3.0. Thanks for watching.